Welcome to our first Flat Earth Thursday on a Monday. I'm releasing this early on Monday, so when this Thursday, when the actual Flat Earth Thursday comes out, there will be more videos on the channel. Today we will be taking a look at Kyle Adams' video, Newton's Failure, Newton's Third Law, where Kyle takes on Professor Dave Explains on Newton's Third Law of Motion. Now let's take a look.
Before arguing about anything, let's talk about what Newton's third law of motion is. Newton's third law states, for every action, there is an equal and opposite reaction.
So far so good. Let's see what you have to say about it. Now the next part of his video, he actually plays Professor Dave's video, so I'm going to skip that. If you want to see his video, go to Professor Dave's video and check it out. It's really good.
As you sit in your chair right now, the force of gravity is pulling you down towards the center of the Earth. But something called the normal force points straight up with the same magnitude, which is why you remain perfectly still.
I'm sorry, Dave, but that chair is not pushing you upward. Though I know Professor Brian Cox claims the Earth is accelerating upward, I'm sorry to burst your bubble, but normal force does not exist.
The gist of the claim that Kyle is making here is that when you push down on an object, it does not push back up, which is the basis for Newton's third law. When something is pressed against the ground is pushing with equal force back into the object.
Every action has an equal and opposite reaction. It means that when two objects interact, there is a force on each object. The magnitude of force on the first object equals the magnitude of force on the second one.
The problem here is that the table is not exerting any upward force on the ball. Forgive me as I exchange the soccer ball for a bowling ball here. But the forces in play in the table are horizontal, not vertical. The reason the ball does not fall through the table is because the strength of the table's molecular bonds is stronger than the weight of the bowling ball. If those bonds were weaker, like they are with water, the molecular bonds that hold the table together would break and the ball would fall right through.
This is absolutely incorrect. When you drop something on an object, you are not breaking the molecular bonds. If you are doing that and dropping a ball on water, the ball would break the molecular bonds of the H2O and it would cease to be water. This is just a ridiculous claim and is not founded on any science whatsoever. Let's keep the example of the water, but let's replace the bowling ball with a human, because we've all belly flopped into water and we know that that hurts. So when a person belly flops into water, the water is pushing back onto the person, causing pain. That is the opposite and equal reaction.
Now, pay attention to this 25-pound weight I have on the floor. Newton's third law states the floor is exerting 25 pounds of force upward onto this weight. Now I'm going to replace that weight with a 5-pound weight. If 25 pounds of upward force were being applied to that 5-pound weight, it should be rising upward. But Newton's third law says that for every action, there is an equal and opposite reaction. This means the upward force from the floor changes. It was applying 25 pounds of force, but now it is only applying 5 pounds of force. So in order for Newton's third law to be true, the floor has to pick and choose exactly how much upward force to apply with each object that rests upon it.
One thing with flat earthers is they do not understand reactionary forces. They say, well, if it pushes up with 25 pounds here or 5 pounds here, it has to choose. And that sounds ridiculous because the floor cannot choose. But it is a reactionary force. Putting 25 pounds down on the floor, the reactionary force is pushing back up. Putting 5 pounds on the floor, the reactionary force is pushing 5 up. It depends on the amount of force that you are pressing down on the floor with.
That doesn't happen with molecular bonds. They are not picking and choosing. The molecular bonds are holding together with the exact same strength the whole time, and the moment that strength is overcome, the object falls through.
Again, that is not how molecular bonds work. Molecular bonds hold two or more atoms together within a molecule. If dropping a bowling ball in water breaks the molecular bond of the water, it would cease to be water and become an H and two oxygens.
Think of a car hitting a brick wall. The car imparts an action force on the wall from its motion, and the wall imparts a reaction force right back on the car, bringing it to a quick stop. These vectors are equal in length and point in opposite directions.
Really, Dave? You claim that wall is pushing on the car with an equal amount of force? Though that car is pushing on the wall, that wall is not pushing back.
If that wall was not pushing back onto the car, why does the car crumble when it hits the wall? That doesn't make sense.
Please tell me that you agree with me that the mass and velocity of a car plus the identical mass and velocity of another car is not going to be the same as the mass and velocity of a car plus the mass and velocity of a stationary wall. According to an auto accident attorney, head-on collisions are the most dangerous because the force of the impact is doubled due to the speed of each vehicle. Therefore, even a relatively slow auto accident with each car traveling just at 25 miles an hour will result in a tremendous impact equal to the force of hitting a wall at 50 miles an hour. This is literally as simple as 1 plus 1 equals 2 and 1 plus 0 equals 1.
Professor Dave uses an analogy of two cars hitting each other head-on. Kyle tries to use the same analogy to disprove opposite and equal reaction. He even quotes a lawyer saying that the lawyer said that two cars traveling 25 miles per hour again hit each other will equal hitting a wall at 50 miles per hour. Now this is interesting because this is something that has been tested before in an episode of Mythbusters. There's a particular episode of Mythbusters where the Mythbusters test two cars running into each other. The myth had nothing to do with Newton's third law, but Jamie did say that two cars hitting each other at 50 miles per hour each is equal to hitting a wall at 100 miles per hour each. And of course, this is incorrect according to Newton's third law. So, later on, they tested this again because of fans' uproar that Jamie was incorrect. So they took two cars and hit them against each other at 50 miles an hour, and then they took one car and hit it against a brick wall at 50 miles an hour, and they compared the damage to the two. The outcome was that the car running into the brick wall at 50 miles an hour was equal to the car that ran into another car, both traveling at 50 miles per hour.
Miles an hour look exactly like the car we smacked into the wall at 50 miles an hour. That tells me everything I need to know.
Well, the figures are in. The orange card got 52 Gs, the yellow card got 58 Gs, which, give or take a few Gs, is the same as what we got against a wall at 50 miles an hour.
Gee whiz. And the damage data backs up those numbers. Both of the cars are virtually the same length as the 50-mile-per-hour wall test at 11.5 feet.
You can quote lawyers all you want, but lawyers do not know physics. This is something that has been tested and proven that two cars running into each other at 50 miles an hour is equivalent to running into a brick wall at 50 miles an hour.
When hammering a nail into a piece of wood, the hammer imparts force onto the nail, and the nail imparts force onto the hammer.
No. If it was an equal and opposite force, the nail should not move at all.
But the nail is driven into the wood because there is a net force acting upon the nail from the motion of the hammer.
Since the nail does not exert an equal and opposite force, it moves. And since it is able to exert enough pressure on a given spot on that wood, it is able to break the molecular bonds within the wood and pass through it.
This last example is an example of a hammer driving a nail into a piece of wood. Now, Professor Dave says now there seems to be a problem with this, that nothing can move. If a hammer is exerting a force onto a nail, and that nail is exerting the same force back onto the hammer, how can the nail move? Now, the forces of the hammer and the nail are equal and opposite. But if you look at only the nail and not the hammer, the nail's net force is downward, and that overcomes the force that the wood is pushing onto the nail, and that pushes the nail through the wood. You have to look at each individual aspect of the Newtonian system. Now, if you disagree with me or you think that there is something that I missed, let me know down in the comments, and let me know if there is a video that you would like me to break down of the Flat Earth community. Come back tomorrow for the first TikTok Tuesday actually on a Tuesday, where I talk about air resistance, inertial reference frames, and pilots making adjustments to fly around the curve. Now come back tomorrow for the first real TikTok Tuesday actually on a Tuesday, where I did... Kitty cat? No, no. No, no. No, no!